Hello students, I hope you all are fine. So today we will keep continue unit 8 aldehyde, ketone and carboxylic acid. As you know, we were doing the method of preparation of aldehyde and ketone. So today we will do one more method of preparation for aldehyde and ketone, that is dehydrogenation of alcohol. Students, we can prepare aldehyde and ketone by alcohol also. But by which method? By dehydrogenation of the alcohol. Dehydrogenation of alcohol means removal of hydrogen. And you know very well, removal of hydrogen is known as the oxidation. Is known as the oxidation. So I can say that oxidation of alcohol also. So students, for example, if I have an alcohol, what is alcohol? Means there will be single bond between carbon and oxygen, and bond group for alcohol is the OH group. Now we will complete the valency. So this one is the alcohol. Students, here we want to do oxidation, means we want to do remove hydrogen. So from where we can remove? We will remove one hydrogen from here and we will remove from one hydrogen from here. Okay. So finally, after removal of the hydrogen, see, one bond with this hydrogen, then one bond with this oxygen. But students, here we are removing two hydrogen. So here oxygen, it will form, because it is bivalent, so it will form two bond with this carbon. Now you can see carbon is tetracovalent. So here 1, 2, 3, 4. 4 bonds it is forming. It is right, and oxygen is forming two bond. So after removal of the hydrogen, alcohols are converting into aldehyde and in ketone also. Okay, I will discuss about that. So they form aldehyde. But student, how does this reaction take place? This reaction will take place in presence of the oxidizing agent. If we take methanol, methanol is CH3OH. This is the methanol. Okay, this is the open structure of the methanol. By oxidation of this one, by oxidation, further what will we do? We will remove the hydrogen, and you know very well removal of hydrogen. One hydrogen we will remove from here and one will from here. So students, what can you get? You can get HCHO. HCHO, this is the methanol. This is methanol or formaldehyde. Formaldehyde means from oxidation of the methanol, we can obtain methanol or formaldehyde. But student, if we have primary alcohol means if carbon is forming only one bond with other carbon, okay, then it is forming two bonds with hydrogen and one bond with this OH group, this oxygen. So this is the primary carbon here. So alcoholic group is attached to this carbon, so it is known as the primary alcohol. Students, if we will do oxidation of this in presence of the potassium permanganate. Potassium permanganate is strong oxidizing agent. Because we are doing the oxidation, and oxidation will take place in presence of the oxidizing agent. And if we do presence of the strong oxidizing agent, that is the KMnO4. So what will happen? First of all, it can oxidize and it can remove one hydrogen from here and one from here. So finally, it can convert into the aldehyde. In aldehyde. But students, because KMnO4 is the strong oxidizing agent, so it can oxidize this aldehyde further. This one is the ethanol. So it can oxidize this further and it can convert into the carboxylic acid. Carboxylic acid. We are doing further oxidation. Oxidation means either addition of oxygen or removal of the hydrogen. In first step, we are removing the hydrogen from here. So it is the oxidation. Again, by further, because one H is again is present here. So addition of oxygen can take place here further. And addition of oxygen is also known as the oxidation. So students, what will happen by oxidation of the primary alcohol? In presence of the strong oxidizing agent, directly we get the carboxylic acid. First of all, it will convert into the aldehyde, but immediately aldehyde will convert into the carboxylic acid. So if we want to obtain aldehyde only, so we need to improve our condition. Either we will take the anhydrous. If we want to stop this reaction up to aldehyde only, so what will condition we take? Here either we can take anhydrous chromium trioxide, or students, sometime this reaction we can do in presence of the PCC. If we do this reaction in presence of the PCC, what is the PCC? PCC is pyrimidine chlorochromate. This is a catalyst. But what type of catalyst it is? It is the inhibitor. It is negative catalyst. It decrease the rate of the reaction. Okay. What will happen then? It will stop this reaction up to the aldehyde only. This is the combination of this is mixture of pyridine. This is pyridine C6H5N. C5H5N, sorry. Plus chromium trioxide plus hydrogen chloride. This is pyrimidine chlorochromate. It is mixture of these three. Okay. So if we proceed this reaction in presence of the PCC, so we can stop the reaction up to aldehyde only. Then we will not get the carboxylic acid. So students, from primary alcohol, by oxidation of them in presence of strong oxidizing agent, we will get the carboxylic acid. But if we want aldehyde only, so either we will do the reaction in presence of the anhydrous chromium oxide, or we will proceed the reaction in presence of PCC. PCC will stop the reaction up to aldehyde only. Okay. So students, from primary alcohol, we can get aldehyde. And from methanol, we can obtain methanol or formaldehyde. But if we have secondary alcohol is if alcohol form bond, if this carbon form bond with other 2 carbon. If the carbon at which alcoholic group is attached, it is forming bond with other 2 carbons, then it is known as the secondary alcohol, and this carbon is secondary. Okay, because alcoholic group is attached to this one, and this is the secondary because it is attached to other 2 carbon atoms. So here this is the secondary alcohol. This is the secondary alcohol. So students, from oxidation of this, either we can take this one, either we can take this one. So we can remove one hydrogen from here and one hydrogen from here. So finally what we will get? We will get CH3, CH3 here, because we are losing 2 valency. So there we will put double bond. Means they convert into the ketone. They convert into the ketone. So from oxidation of the secondary alcohol, we get ketone. We get ketone. From methanol, oxidation of the methanol, we will get formaldehyde. From oxidation of primary alcohol, we will get aldehyde. And from oxidation of secondary alcohol, we will get ketones. Respective ketone we will get. Okay. Students, secondary alcohol do not give carboxylic acid. Why? Because in case of the primary alcohol, it first convert into aldehyde. So one more hydrogen is present here. Okay, so reaction can further proceed. But here, in case of ketone, now there is no more hydrogen. Okay, so it cannot further oxidize. So from secondary alcohol, we will get ketone only. This reaction will not go up to the carboxylic acid formation. So we can get the carboxylic acid from primary alcohol only, primary alcohol only, not from the secondary alcohol. But if we have tertiary alcohol, students, tertiary alcohol do not give the reaction, do not proceed oxidation or dehydrogenation in simple condition. Reaction can be take place in drastic condition, otherwise in simple conditions reaction do not take place. And if reaction we proceed in drastic conditions, this is the tertiary alcohol. Okay, this one is the tertiary alcohol. So if we do the reaction in drastic conditions, okay, at high temperature, high pressure, in presence of strong oxidizing agent, then reaction can take place. But here bond will not break between oxygen, hydrogen and carbon, hydrogen. Here bond will break between carbon to carbon. This, what will happen here? I can write this in this way. So this bond will shifted here, and from here removal of water. Removal of water take place and formation of alkene take place here. Dehydration take place in that. Alkene formation will be there if we have tertiary alcohol. If we have methanol, then we get formaldehyde. You will keep in your mind these points. If we have primary alcohol, then by oxidation we get aldehyde. Secondary alcohol gives ketone, and oxidation of tertiary alcohol we cannot do in simple conditions, in normal conditions, in presence of strong oxidizing agent, their dehydration take place and they can convert into the alkene. Okay students, sometimes same reactions we can proceed when vapors of the when vapors of alcohol pass through copper, copper at 573 Kelvin. Then further they produce the same product. Further, if we have methanol, alcohol should be volatile here. Means we will take vapor form of the alcohol. If we pass vapor of the alcohol through copper at 573 Kelvin, then further methanol will give formaldehyde. Primary alcohol, when vapor of primary alcohol pass through copper at 573 Kelvin, then they give us aldehyde. And secondary alcohol, again they will give us ketone. They give us ketone. And students, further, if we have tertiary alcohol and vapor of that pass through the copper at 573 Kelvin, then their dehydration take place. Further dehydration of tertiary alcohol take place and removal of water take place from here, and finally formation of alkene will take place. One condition is there when we pass the alcohol through copper. Here alcohol should be volatile because we will pass vapors of the alcohol. So it must be the volatile because volatile substance create vapors. Non-volatile cannot be converted into the vapors. Okay students, so this is all about the dehydrogenation of the alcohol. Either we can do in presence of the strong oxidizing agent. If we do the oxidation in presence of strong oxidizing agent, so primary alcohol can directly convert into carboxylic acid. So either we will proceed the reaction in mild oxidizing agent or in presence of the PCC, and we can get the aldehyde and ketone by passing through the copper rod also. So in this way we will get. So thank you, have a nice day.